Welcome to Electrochemistry Lecture 2. The next topic is molar conductance and equivalent conductance. First is a molar conductance. Conductance of 1 mole of electrolyte can be represented by the lambda m. Now we know that if L is equal to 1 centimeter, A is equal to 1 centimeter square, then the volume will be 1 centimeter cube. And for 1 centimeter cube volume, the electrolyte is equal to K, means kappa. Okay, then for V centimeter cube, it will be K multiplied by V. Now, concentration can be represented in the terms of molarity for electrolyte. So now if concentration of electrolyte is M, then M mole of electrolyte in 1 liter volume means 1000 centimeter cube. So for a 1 mole of electrolyte, it will be lambda m is equal to K multiplied by 1000 upon M. We know the unit of kappa, that is mole inverse centimeter inverse, and for molarity is mole per liter, but 1 liter means a 1000 centimeter cube. So finally the unit is mole inverse, or we can say it is ohm inverse, or we can say mho or Siemens into centimeter square into mole inverse. Okay, now if K is given in ohm inverse, meter inverse, okay, then K lambda m is equal to K into 1000 upon M into 10 raised to minus 6, because we have to convert the centimeter cube to meter cube. Fine. So we have to multiply this equation with the 10 raised to minus 6. So the unit will be ohm inverse meter square and a mole inverse. Okay. Now the next topic is equivalent conductance. Conductance of one equivalent of an electrolyte, lambda eq is equal to K into 1000 upon N. N means what? Normality. Okay. So unit will be ohm inverse or a mho or Siemens into centimeter square into equivalent inverse. The relation between lambda m and lambda equivalent. Okay, it is normality upon molarity is equal to n factor. This n is for what? N factor is for, also known as volume factor. This is for acid, it can be calculated based on H plus ion. For base, it can be calculated based on OH minus ion, and for metals it will be based on its charge. Okay, so the formula will be lambda m is equal to n factor multiplied by lambda equivalent. So this formula is very important, and number of MCQ questions will be asked based on this formula. Now next is the factors affecting electrolytic conductance. Okay, number of MCQ questions will become from this. So the concept should be clear in your mind. First thing is that ionic interaction. If ions will interact with each other, then the conductance will be decreased. Okay. Next is nature of solvent. Okay. Based on nature of solvent, if dielectric constant is more, if ionization is more, then conductance will be more. Okay, more the number of ions, more will be the conduction. Next is viscosity. Means if a liquid is semi-solid or a viscous, okay, then the conductance will be less because separation into ions will be less. Listen, ions here are the carriers, okay, to carry a electric current. So if ions will be less, then conductance will be less. The next thing is solvation or hydration of ions. Hydration means if you dilute solution, then what happens? Volume increase, but the molarity getting decrease. And if molarity is decreased, the number of ions per unit volume decrease and ions decrease. So conductance will be less. Okay. Now if we consider one example by taking a group 1 element, ionic compound with the group 1 element, okay, lithium, sodium, potassium, rubidium and a cesium. So as we move down a group, we can say size increase. So intermolecular force of attraction, what? decrease, hydration increase. Okay, means more ions can be dissolved, or separation of ions will be more. That's why conductance will be more. Next is the effect of dilution. If we dilute solution, then ionization will be more and conductance will be more. Okay, if again we increase dilution, then volume increase, molarity decrease, lambda m increase, and a conductance decrease. Okay, listen, we know the formula. Okay, lambda m is equal to K into 1000 upon m. So lambda m has a vice versa relation with the molarity. Similarly, lambda equivalent has a vice versa relation with the normality. So if lambda equivalent or lambda m increase, then molarity or normality decrease. And if a molarity and a normality decrease, then the concentration is less. And if concentration will be less, then ions will be less. And if ions will be less, then conductance will be less. Next is a molar conductance and infinite dilution or a zero. हम डाइल्यूट करके एक ऐसे स्टेज पे आ जा रहे हैं जहां पे अभी डाइल्यूशन एंड तक हो गया है, मीन्स कॉन्सेंट्रेशन हमने जीरो कर लिया है. So that can be represented by the Debye-Huckel-Onsker equation. That is lambda m, that is a molar conductivity at concentration, at any concentration. Lambda naught m, molar conductance at infinite or a zero concentration. B is the Debye constant. At constant temperature, it is same for same type of electrolyte. Okay, same type, different type of electrolyte we will see in a detail. And a square root of Cc means nothing but a concentration. For NaCl, we know that Na plus and Cl minus, so ratio will be 1:1. For KCl, K plus Cl minus, it will be 1:1. Mg plus 2 and a Cl minus 2:1. Na plus 1 and SO4 minus 2, so it will be 1:2. Mg plus 2 and SO4 minus 2, so 2:T. Here we have a graph. Listen, if we plot a graph, then y is equal to mx plus c. This is our intercept values. Okay, you can see here. On y-axis, we need to take a molar conductivity. Y is equal to mx minus b will be the slope. On x-axis, we need to take a square root of concentration. We have plotted a graph for one strong electrolyte, that is KCl, and another weak electrolyte, that is CH3COOH. For strong electrolyte, we know that alpha is equal to 1 and ionization is complete. Okay, so graph will be obtained in a straight line. Means lambda m decreases on increasing concentration. Okay, and for a weak electrolyte, initially lambda m decreases, and then lambda m concentration increases. Okay, and lambda m remains constant. Okay, so this is the graph. And even in your JEE and NEET, the question will be asked from this section. But yes, not in a board, only in JEE and NEET. Okay, thank you for watching this video and wait for my video 3.